Axelar network. Connecting applications with blockchain ecosystems. Multiple blockchain ecosystems are emerging that provide unique and distinct features attractive to users and application developers. However, communication across the ecosystems is very sparse and fragmented. To enable applications to communicate across blockchain ecosystems frictionlessly, we propose Axelar. Axelar Stack provides a decentralized network, protocols, tools, and APIs that allow simple cross-chain communication. Axelar Protocol Suite consists of cross-border routing and transfer protocols. A decentralized open network of validators powers the network. Anyone can join, use it, and participate. Byzantine consensus, cryptography, and incentive mechanisms are designed to achieve high safety and liveness requirements unique for cross-chain requests. To bridge the blockchain ecosystems and enable applications to communicate frictionlessly across them, we propose Axelar network. Validators collectively run a Byzantine consensus protocol and run the protocols facilitating cross-chain requests. Anyone can join the network, participate, and use it. The underlying network is optimized for high safety and liveness requirements unique for cross-chain requests. Axelar network also includes a protocol suite and APIs. The core protocols are Cross-Chain Gateway Protocol, CGP. This protocol is analogous to Border Gateway Protocol on the Internet. This protocol is used to connect multiple autonomous blockchain ecosystems and is responsible for routing across them. Blockchains do not need to speak any custom language, their platform developers do not need to make any custom changes on their chains, and their chains can be plugged into the global network easily. Cross-Chain Transfer Protocol, CTP. This protocol is analogous to application-level protocols file transfer, hypertext transfer protocols on the Internet. It is an application-level protocol stack that sits on top of routing protocols, such as CGP and other routing technologies. Application developers can connect their dApps on any chain to perform cross-chain requests. Users can use the CTP protocol to interact with applications on any chain using simple API calls analogous to HTTP GET POST requests. At the core, cross-chain communication requires that heterogeneous networks find the ability to communicate using the same language. To solve this, we explain the Axelar protocol suite, describe its high-level properties, and explain how these properties address the core of scalable cross-chain communication. 1. Plug-and-play integration. Blockchain platform builders should not be required to perform heavy engineering or integration work to speak some custom language to support cross-chain. The cross-chain protocol should be able to plug in any existing or new blockchain frictionlessly. New assets should be added with minimal effort. 2. Cross-chain routing. Functions such as the discovery of network addresses, routing paths, and networks are at the core of the Internet and facilitated by BGP and other routing protocols. Similarly, to facilitate communication across blockchain ecosystems, we need to support the discovery of addresses across them, applications, and routing. 3. Upgradability support. If one of the blockchain ecosystems changes, it should not affect the interoperability of other blockchains. The system needs to recognize updates, and minimal effort should be required to support them, i.e., no state transition logic should be rewritten, and applications should not break. 4. Uniform language for applications. Applications need a simple protocol to lock, unlock, transfer, and communicate with other applications no matter which chain they reside on. This protocol must be chain agnostic and support simple calls, analogous to HTTP/HTTPS protocols that allow users and browsers to communicate with any web server. As more networks and assets join the lower-level routing protocols, applications should be able to use them for communications without rewriting their software stacks. Next, we summarize the security requirements that these protocols must meet. 1. Decentralized trust. The network and protocols must be decentralized, open, and allow everyone to participate fairly. 2. High safety. the system must satisfy high safety guarantees. The system needs to preserve the safety of assets and the state as the cross-chain network processes it. 3. High liveness. The system must satisfy high liveness guarantees to support applications leveraging its cross-chain features. The security of blockchain systems relies on various cryptographic and game-theoretic protocols, as well as the decentralization of the network. For instance, in proof-of-stake blockchains, without the proper incentives, validators may collude and rewrite the history, stealing other users' funds in the process. In proof-of-work networks, without sufficient decentralization, it is quite easy to create long forks and double spend, as the multiple attacks on Bitcoin Gold and Ethereum Classic have proven. Most of the research on blockchain security has focused on sovereign chains. But once chains interoperate, new attack vectors have to be considered. For instance, assume that Ethereum talks to a small blockchain X through a direct bridge controlled by two smart contracts, one on Ethereum and one on X. Besides the engineering challenges we summarized in section 1.1, when the trust assumptions of X are violated. In this case, if ETH has moved to X, the validators of X may collude to forge a history of X where they hold all the ETH, post the forged consensus proofs on Ethereum and steal the ETH. The situation is even worse when X is connected with multiple other chains through direct bridges, where if X forks, the effects propagate through every bridge. Setting up recovery governance guidelines for each pairwise bridge is an overwhelming task for any individual project. Axelar network addresses the security concerns using the following mechanisms. Maximum safety. Axelar sets the safety threshold to 90%, meaning that almost all validators will need to collude to withdraw any funds that are locked by its network or forge state proofs. 1. In practice, it has been observed that POS validators have very high uptime, close to 100%, assuming they are properly incentivized. Hence, Axelar network will produce blocks even despite this high threshold. However, in the rare case that something goes wrong and the network stalls, the network needs robust fallback mechanisms to reboot the system described next. Maximum decentralization. Since the network uses threshold signature schemes, the number of validators can be as large as possible. The network is not bounded by the number of validators we can support, transaction limits or fees that would arise from using, for instance, multi-signatures on different chains where the complexity and fees increase linearly with the number of validators. 2. Robust fallback mechanisms. The first question that must be addressed in a network with high safety thresholds as above is what happens when the network itself stalls. Suppose Axelar network itself stalls. Can we have a fallback mechanism that would allow users to recover their funds? To address any potential stall of the Axelar network itself, each threshold bridge account on a blockchain X that the Axelar validators collectively control has an emergency unlock key. This key can be shared 8. across thousands of parties and may even be a custom key for blockchain X that is shared across the community of that chain. Hence, if Axelar network stalls, this key will act as a fallback and enable recovery of the assets. See below for more details. Maximum decentralization of fallback mechanisms. This fallback mechanism includes a secondary recovery set of users, in which just anyone can participate without any cost. These users do not need to be online, run nodes, or coordinate with each other. They are only called on duty if Axelar network stalls and cannot recover. The network's security is enhanced by a very high threshold on the primary validator set and a maximally decentralized secondary recovery set. Shared governance. A common protocol governs the Axelar network. Collectively, the users can vote on which chain should be supported through its network. The network will also allocate a pool of funds that can be used to reimburse users in case of unexpected emergencies, controlled via the governance protocols as well.